Hello students, my name is Abhru Puttacharji. I have done my masters in mathematics from NIT Silchar and I will be teaching you mathematics. So today what I am going to start is functions. Functions is a very important chapter in mathematics. It has its application in physics, chemistry and all other branches of science, especially in computational science. Wherever there is computation, we need functions. So what is a function? The first thing is, what is a function? Remember, function is a mathematical machine. It's a mathematical machine in which you give some input, and for that input we get a definite output. What any machine do? In suppose you have a factory in which there is a rice factory. Okay, there are machines in which you give certain grains and in the output we get rice, right? Or there is a juicer in which you give fruits as inputs and you get juice out of it as output. Okay, so what is a function? Function is a mathematical tool, is a mathematical machine. Suppose this is a mathematical machine, okay, in which, and it is denoted by f of x. F of x. It is not f into x, which some of you from after doing a 10th grade mathematics, you might think that this is f into x, but this is how we denote functions. It is not f into x, it is f of x. This is how a function is denoted. Here, what is x? X is the input value. X is the input value that we give input into the machine. That is input value. Input. What is x? X is the input value. Okay. And what is the output that we are getting? We are getting f of x. This is output value. This is output value. Okay. So we give an input value, and for a particular unique input value, we will get a unique output value. We can't give for one input value, we can't get two output values. Okay, this is not possible for a function. That is, for one input value, we will get one output value, right? So in class 10th up to class 10th grade, we have all studied function, but we have not. You were not introduced to functions, but you have studied it. Where? You have studied it in straight lines. Okay, what is a straight line? What is the gradient form of a straight line? Y equals to mx plus c. Okay, here m and c are what? M is the gradient and c is the intercept. These are constant values. So for a particular, and we also plotted the graph of y equals to m of x. Mx plus c, and what does it give? It gives a straight line. It gives a straight line. You have all studied it in your up to class 10th level, right? So but you were not told that it is a function. It is a function, right? It is a function because for each input value x, we get an output value y, right? So the first type of function that we have studied, we can also already give example. Okay, example of a function. That is first example. Let me take f of x. Here f of x equals to, suppose, 2x plus 3, right? 2x plus 3. Here we can see that here f of x equals to 2x plus 3. It is nothing but a linear function, because if you replace fx by y, then for each x we will get an output y or fx. Okay, so this type of functions are called linear functions. Linear functions. Okay, we have already studied how to plot. You know how to plot a straight line. Okay, we take x values. And we get, here we will write f of x. Suppose we put x equals to 1. Then what will be f of 1? F of 1 will be what? 2 into 1 plus 3, right? That is 5. That is 5. Similarly, you can take x equals to 2. X equals to 2, then f of 2. F of 2. Okay. So if you put x equals to 2, then you will get 2 into 2 plus 3. That is 4 plus 3 equals to 7. And if you plot for different x the values of fx, you will get a straight line. That is, if you, okay, let me show you in the next slide. So for this linear function fx equals to 2x plus 3, we have taken some inputs. We have given some input values of x, and we have found out some output values of fx. Okay, and if you plot this, suppose if you take x as this x-axis, along x-axis, and if you plot fx along y-axis, if you plot fx along y-axis, then it will surely be giving a straight line with intercept of 3, like this. Okay, here it is 3. So you will get a straight line, and that's why it is called linear function. It is called linear function. Okay, any linear function gives a straight line when you plot it in xy Cartesian coordinate. Xy Cartesian coordinate. Then you will get a straight line. Okay, that's why these functions are called linear functions. Any function, any mathematical function, we can draw graph of that function, right? We can plot the values of x and values of y output, and we can plot the graphs. Let me give you some more examples of functions. Okay. So the next example of function which we are taking is fx equals to x square. Here I have put some values of x, and that is the input values. We have taken just 5 values, and we have found out the corresponding output values. And see, I have plotted here the input and output points. That is for -2. This is -2 comma 4. This point is -2 comma 4. Then this is -1 comma -1 This point is -1 comma 1. Then 0 comma 0. Then 1 comma 1. Then 2 comma 4. Right. Here it seems like a straight line here and a straight line there, but if you take all the intermediate values, that is, if you take -1.9999, then -1.8, -1. If you take the closer values of x and fx, then you will find that it is a little bit curved along this side, and there is a slope. Okay, the curve is steeper, and again this it is going upwards in that direction, right? So this type of function is called quadratic function. This type of function is called quadratic function. Quadratic function, where the power of x, that is the power of input, is squared. The power of input is 2, right? So we will get the graph of this function is a parabola. Specifically, the graph of this function is a parabola. Okay, it is called a parabola. Whenever we draw a quadratic function, we draw the graph of a quadratic function, then graph of a quadratic function, then we get a parabola. Okay. So we have already seen how a linear function and quadratic function look. Right. Now we will be looking at cubic function, that is fx equals to x cube. I am just showing you the graph of fx equals to x cube and how it looks like. Right. So this is our y-axis, this is our x-axis. Right. So it starts right here, down here, and it goes up like this, just touches the origin here, and then it goes back like this. right? So this is how a cubic graph looks like. Okay. So the next function we will be looking at is the modulus function or the absolute value function, and it is represented by this fx equals to mod of x, right? So what it does, what this function does is, if you put negative values of x, it gives positive result. For positive values of x, we get obviously positive results. Also for negative values of x, we get positive output. So let me write some inputs and outputs here. Okay, for fx equals to suppose -2, how much we will get? F of -2 equals to mod of -2, that is, we'll simply get 2 back. Okay, again for -1 we will get 1, for 0 we get 0, 1, for 1 we get 1, for 1 we get 1, and for 2 we get 2. For negative values we get just the absolute value of that negative number. Okay, this is for -2 we get 2, for -1 we get 1, for -1.5 we get 1.5. If you plot the graph of this function, you will get it like this. Okay, and then just the mirror image on that side. Okay, so this is y equals to mod of x. Okay, we are getting to the whole graph is in the upward side of y-axis, because we get all the positive values of y. We get all the, this is what absolute value function does. For any negative values of x, we are getting positive values of y. Okay. So the next function is that we have taken is 1 by x. Here you can see that if you take very small values of x, then you will get a very large value of fx, and if you keep on increasing the values of x, then the value of fx keeps on decreasing. Okay, so how the graph will look like, let me show you. Let me show you. For very small values of x, we will be getting very large values of y. So it will be starting from here, and it will keep on decreasing. And for very large values of x, we will get very small values of y. Okay. This, you can see that this curve will never touch the x-axis. It will never touch the y-axis. Why? Because there is no value of x for which y can be 0. There is no value of x for which fx can be 0. Okay. Similarly, there is no value of fx for which x can be 0. So it will neither touch y-axis, it will not touch x-axis. Also, if you take the negative values of x, so for very small negative values of x, we will be getting very large negative values of y. Okay, and then for large negative values of x, we will be getting small negative values of y. So this is the graph of fx equals to 1 by x. It goes infinite and along that side, and it goes infinite along that side. The graph will never touch x-axis and nor y-axis. Okay, so this is a function. We can use this function whenever we need to get very large output for a very small amount of x. For very small input, if we want a very large output, then we can use this function, right? So in this video we have studied what is a function and some of the examples of functions, that is linear function, quadratic function, cubic function, then modulus function. Okay, in the next video we will study some more types of functions, that is trigonometric functions and the graph of trigonometric functions, and then we will proceed to what is domain and range of function. Okay, so thank you for watching the video and I hope you liked it.